Welcome, calculus students. This is Kim Breeden at Minnesota Online High School, and in this video, we're going to introduce U substitution. To understand this, it's important to remember that derivatives and integrals are opposites. So let's start with an easy example. So if we have the equation y equals x squared, we all know that the derivative of that is 2x. This means that if we have the integral of 2x dx, its antiderivative is x squared. Those are the type of problems that you've been doing so far. They've looked fairly simple in format, and so it's probably easy to see that connection between the derivative and the antiderivative. However, you know that you've done much more complex derivatives, and sometimes our answers look pretty complex or messy. For example, imagine that you were asked to find the derivative of 3x squared plus 8 all to the fourth power. Hopefully you remember that you would have to use the chain rule. So remember, we multiply that 4 down in front, keep the inside the same, 3x squared plus 8. Now that's to the third power. And then we multiply it by the derivative of the inside. The inside has a derivative of 6x. Therefore, our derivative, y prime, equals 24x times 3x squared plus 8 to the third power. Now, in terms of integrals, you might be asked to find the derivative of 24x times 3x squared plus 8 to the third power dx. Now, because we just found that derivative, we know that that is equal to 3x squared plus 8 to the fourth power. However, you probably would not naturally see that. In order to find that antiderivative, we would have to use U substitution. The chain rule and U substitution are opposites. So if you used the chain rule to find the derivative, we'll have to use U substitution to find the original, or the integral. Let's talk about some of the basics of U substitution. First off, you might not know when to use U substitution. If you look at the integrand, that's the part of the integral without the dx. Think about how you would take the derivative of that. If you would need to use the chain rule to take the derivative, you'll need U substitution for the integral. And our goal of U substitution is to make this look like a simpler problem. You can find the integral if it was something simple looking, like the integral of U du. We're going to do quite a few examples together, but I know some people really like to have a layout and a very linear step-by-step process. So here's what happens in U substitution. We're going to take and we're going to define U as a part, typically the inside of our integral. This could take a little bit of practice. Then we take the derivative of U, and we're going to write it as du equals something in relation to dx. Here is where we have to do a little bit of checking. We have to make sure that in our original problem, we have at least the x term that was part of our du. We're going to want things to cancel out. We're not going to worry necessarily about the coefficients. Then we go back to, we're going to solve that du equation for dx. Then in step 5, we're going to substitute. So we're going to take and substitute in what we've solved for du, as well as what we solved for u. We're going to replace just two things. In step 6, we're going to simplify. If we did it right, all of our x terms should cancel out, and we should have things only in terms of u. If not, we might have made a mistake somewhere. By step 7, we have a simpler problem. we're going to use the skills you've previously learned to find the integral. Then in step 8, at the very end, we need to put things back in terms of x. So we're going to substitute our values back in. This will make more sense after we do a few examples. Let's look at an example. Our first example is the integral of 3x minus 4 to the 5th power. We've not found an integral where we had a binomial to the power. We will have to use u substitution. So our first step is to define u. Typically, we define u as the inside of our integrand. In this case, we're going to define u as 3x minus 4. Step 2 says that we want to find the derivative of u. This means that du is going to equal 3 dx. And we write dx so that we indicate that we took the derivative in terms of x. Step 3, I'm going to compare and look back at the original problem. The key thing that I'm checking is the exponents of my variable. I don't have an x in my du, and I don't have an x in my integral outside of that inside, so I'm doing okay. Now we're going to solve this for dx. I'm going to divide both sides by 3. So dx is equal to du divided by 3. Now in step 5, we're going back to the original integral problem, and we're going to substitute in. So our original problem was 3x minus 4 to the 5th power. Okay, we said that u was 3x minus 4. So this is actually written now as u to the 5th. And instead of dx, we solved dx to say that dx was equal to du divided by 3. I could rewrite that as u to the 5th times 1/3 du. The reason I did that is it might make more sense to be able to pull that constant, that coefficient out in front. So now I have the 1/3 times the integral of u to the 5th du. These are the types of problems that you've been solving so far. Your antiderivative rules you've learned so far. Remember, what we're going to do is this time we raise the exponent by 1. So that becomes u to the 6th divided by 6. Always remember your plus c. Now we want our answer in terms of x. So we're going to start. I'm going to start by multiplying the 1/3 and the divided by 6. So that gives me 1/18. It was u to the 6th. Well, remember, way back up here at the beginning of our problem, we defined u as 3x minus 4. So I substitute 3x minus 4 in for u. That is to the 6th power. And then plus c. Now, let's say you weren't confident in your answer. You can always check. So I'm not going to do this all the time, but on this first one, let's double check and see what happened. So remember, integrals and derivatives are opposite. That means if I take the derivative of this answer, I should get the integral. So imagine that y equals what we just had as our answer, 1/18 times 3x minus 4 to the 6th power plus c. Let's find the derivative. Okay, so we're going to use the chain rule. We start by multiplying that 6 down in front. So 1/18 times 6. Keep our inside the same. 3x minus 4. We reduce our power, so that's to the 5th power. Times it by the derivative of the inside. Derivative of the inside is 3. The derivative of that constant plus c, well, that's going to be 0. So that's why it cancels out. So if I simplify this down, 1/18 times 6 times 3, well, that cancels. So I am left with my derivative of 3x minus 4 to the 5th power. And if you look back, that was our original problem. So we did it correct. Let's try another one. Okay, so number 2 is a little bit more complex. 6x squared times x to the 3rd plus 4 to the 5th power. Let's start by defining our u as the inside. So we will say that u equals x cubed plus 4. We find the derivative. So du equals 3x squared dx. Steps 1 and 2. Okay, now I'm going to pause for step 3, and I'm going to go back and look at the original problem. I'm going to look at the part that's not my u. So looking at this part, and what I want to see is that my du contains the variable to the same exponent. So I have 3x squared. I'm feeling like I'm on the right track. Step 4, I'm going to solve that equation for dx. So I will need to divide both sides by 3x squared. And that leaves me with dx equals du over 3x squared. Step 5, I'm going back to the original problem and substituting in. Now the key thing to remember is that I'm only substituting in 2 places. First, for what I defined u to be, and second, for what I've solved for dx. So at this point, leave everything else the same. So I still have 6x squared times u to the 5th power times dx. Well, I know that dx was du over 3x squared. Now, if we did that right, as we get to step 6, we should simplify down. Okay, I have a du divided by 3x squared. So that 3x squared and the 6x squared are going to simplify down. So that gives me an integral now of just 2 u to the 5th du. That constant doesn't matter. I can now integrate that. I'm going to raise my power by 1. So 2u to the 6th, divide by that new power, so plus, or divided by 6. And again, always remember C. We want our final answer in terms of x. So we're going to substitute back in. First off, 2 divided by 6, well, that reduces down to 1/3. And instead of u, I'm going to go back to the very beginning. I defined u as x cubed plus 4. So that was u to the 6th power plus c. Number 3, the integral of the square root of x minus 1 squared divided by the square root of x. Okay, so you might think this looks like kind of a complex problem. We're going to try to simplify it down. You might wonder, what do I define as u? Again, after you do more of these, it's going to feel more natural. But typically, look at the inside of the larger complex part. So I'm going to define u as that top. So u will equal the square root of x minus 1. The derivative of that, you might want to rewrite this as x to the 1/2 power minus 1. So when I take the derivative, du is going to equal 1/2 x to the negative 1/2 power dx. I can rewrite that to get rid of my negative exponent. So I can rewrite that as 1 over 2 times the square root of x dx. I'm going to delete some of those inside steps so I have more room. I need to now solve this for dx, which means I'm going to multiply both sides by 1 over, or multiply both sides by 2 times the square root of x. So dx is equal to 2 times the square root of x du. And back in step 3, I should have verified and noticed, oh, my du has a square root of x. There was a square root of x in the problem. Okay, now we're going to go substitute everything back in. So back in my integral, well, the top would be u squared. Remember, I'm not changing anything in that square root of x. There's nothing to substitute in. But then instead of dx, I can write down 2 square root of x du. Here things are going to cancel out and simplify. Our square root of x's canceled out. We have the integral of 2u squared du. Using our basic integration rules, the integral of that would be 2u to the third power divided by 3 plus c. Substitute back in, so our answer is in terms of x. U was the square root of x minus 1. So 2 times the square root of x minus 1 to the third power divided by 3 plus c. Thanks for sticking with me. We'll do one last example. The integral of sine x e to the cosine x. Definitely the most complex looking one we've done so far. In order to decide what I'm going to define for you, think about what I would do if I were finding the derivative. Where would I need to use the chain rule? I'd have to use the chain rule in this part. So I'm going to use cosine x as my inside term and define that as u. I'm going to define u equals cosine x. Find the derivative of that. Negative sine x dx. I want to solve that for dx. And that's going to give me du divided by negative sine x is going to equal dx. Let's plug our pieces back into our integral. You might want to go back up to the original problem and confirm where you are substituting in. Remember, I'll substitute in for what I defined for u, as well as what dx is equal to. So therefore, we are looking for the integral of sine x e to the u power, and then dx is du divided by negative sine x. Simplifying this down, our sines cancel out. So we are left with, simplified down, negative e to the u power du. So my integral would be negative e to the u plus c. Substitute in u. So I have negative e to the cosine x power plus c. Excellent job. You're now going to practice some u substitution, and we'll come back and look at some more complex examples later.